Amides. Amides are hydrocarbon derivatives, and they have a carbonyl group that is attached to a nitrogen. And you can have primary, secondary, and tertiary amides. Or carboxylic acid reacts with an amine or ammonia, and that's how you form amides. And this is going to be used to help name the compounds produce the amides. So a carboxylic acid with a C double bond O, OH, will react with an amine to form an amide plus water. So the water actually comes off here. The OH from the acid and an H from the amine make water, and it forms an amide linkage. Okay, naming amides. So identify the portion that contains the carbonyl group, and that's going to become the root of your name. You're going to drop the E from the length of it as an alkane and add the word amide. If there's any side groups on that chain, you're going to name them, like methyl or ethyl, and you're going to put in a number for where they are relative to the C double bond O. And this prefix is going to be attached to the root name, so something amide. If there's other carbon chains attached to the nitrogen, you're going to name them as an N-alkyl group. And we're going to do those alphabetically in front. All right, if we look at this structure, here we have the portion containing the carbonyl group. So this is going to be our root. And it has a side group on it here. So this portion will be our amide portion. So there's 1, 2, 3, 4 carbons in our longest carbon chain. So this becomes bute and amide. Take the E off of butane and add amide. So butanamide, amide. And there is a methyl group, and it would be on carbon number 2, because the carbonyl group is carbon number 1. So this is 2-methyl butanamide. So the amide portion is done. Now we're going to look at the rest of the compound. So we have to put in something for the CH3. So the CH3 is a methyl group, and that's all there is. So this is N-methyl, 2-methyl butanamide. N-methyl for the CH3 group, 2-methyl butanamide. Now this would be considered a secondary amide because the nitrogen is bonded to 2 carbons. So this is a secondary amide. So drawing an amide, draw the root, draw out the carbons, and place your nitrogen. If there's a prefix attached to the root name, and that would mean it would come right in front of the word that contains amide, add the side group to the carbon chain at the appropriate place given by the number. The prefixes before the name are any of the carbon chains attached to the nitrogen. If appropriate, if nitrogen doesn't have 3 bonds, you're going to add hydrogens to it. So the structure propanamide. So that tells us that there's a carbon chain that is 3 carbons long because of the prop. So 1, 2, 3. There's our carbonyl group. There's our nitrogen. So because there's no other group, there's no N anything, we know that these 2 bonds on nitrogen are only to hydrogens. So here is propanamide. All right, N-ethyl and propylpropanamide. So this tells us, propanamide tells us that it's a carbonyl group attached to two other carbons, so the carbon chain length is 3. And attached to the nitrogen, you have two other groups. One is an ethyl group and one is a propyl group. So here's our 3 for your propanamide. There's your N, and now you need 3 total bonds. So one is an ethyl group. Let's move this up just a smidge. Here's your ethyl group, and we also need another propyl group, 3 carbons. So here's your structure. You'd have to throw in your hydrogens. So you've got an ethyl group, an ethyl, and propyl propanamide. Physical properties. Okay, so the carbonyl group is polar, and if you have a primary or secondary amide, you've got London dispersion forces and dipole-dipole forces. The NH portion is very polar and can make hydrogen bonds, so we can have very high boiling points. In terms of solubility, the carbonyl group can accept hydrogen bonds, as can the lone pair of electrons on the nitrogen. And if any hydrogen is bonded to the nitrogen, these can also make hydrogen bonds with water. So small amides are very soluble in water. In terms of polarity, the amide is the most polar, followed by carboxylic acids, then alcohols, then ketones and aldehydes. This is more polar than an amine, an ester, an ether, and an alkane.